Good morning, class. I wanted to take the opportunity to go through a little bit of our milestone assignment for this week. And what we're going to do is we're going to build one of the classes that is a requirement as a way of discussing what those should look like. So if we go take a look at our requirements, we're going to start with one of these entree classes. And I think we will tackle the BriarheartBurger. So the BriarheartBurger should, like all of these, implement a price, calories, and special instructions. And it should override the toString function to return a string saying that it is a BriarheartBurger. So that's the expected return value. And then the details on that, the price should be $6.32. It should return $7.34 for the calories. It should have Boolean properties for bun, ketchup, mustard, pickle, and cheese. And then it should have a special instructions list, which would offer each one of those special instructions. So what will that look like? Well, first of all, we're going to need to create a folder for our entrees. Now, these don't necessarily have to go into their own folder, but that's often how namespaces are implemented in Visual Studio. And if we go ahead and create the folder, it will automatically, when we put files in it, they will automatically receive that namespace. So, for example, this Bleakman buffet.data.enums namespace. So if we do an entree, and then inside of that we add to it a class, and we want to call this BriarheartBurger, and we want to define it in a class that's BriarheartBurger or a file that's BriarheartBurger.cs. Now the first thing we need to do is we want this to be a public class. Remember our discussion of accessors. We want to make sure that this is usable outside of the class. And then inside the class, we're going to implement properties for price, for example, which is a double. And we need a getter that's going to return the price, which for the BriarheartBurger is $6.32. So a fairly affordable burger. Now if we go back and look at our requirements, should implement a property for price. That price is $6.32. Question becomes, do we need to change this at any point? And we don't, so we can actually use a static value just like this. Another way we could do it is we could create a private backing variable and return that value. And this is perfectly fine, and especially if we think we might go back in later and need to modify how some of this behaves, it might be a good idea to do that. However, since this price is never going to change, we can certainly just do 6.32. Now, if you read through Microsoft's documentation on properties, you probably noticed that there are a number of different ways we can also write this. For example, we can substitute lambda syntax to say that we want a getter that is going to return, and we don't need the return statement, of 6.32. Also, since this is technically a read-only property, it only has a getter, there is no setter, we could even simplify that more, and we can say price lambda arrow 6.32. These different options are something we call syntactic sugar, so they're ways of doing things that were already there in the language, but when they started adding lambda syntax, they started saying, let's make it easier and faster for people to write these properties. So this lambda syntax obviously is a little bit faster to write for read-only property. We can very quickly kick that out. So we can write our getters and setters like that. And of course, if we're going to document it's the price of the burger, we want to throw a summary above each one of these. Then we need public double calories. And again, calories is going to be a read-only property. We can look and we can see there's nothing changing about it. So we could just use the uint 743, although this should be a uint for an unsigned integer, because we're never going to have negative calories. Wouldn't that be nice? But that is not a possibility, so we can go ahead and do it that way. Oh, uint, not unit. There we go. And then we have special instructions, which is going to be a list of string. We'll come back to that one. Let's go ahead and document this. Now we also have Boolean properties for bun, ketchup, mustard, pickle, and cheese. So we need to add all of those. Because those will be changeable, those are both read and write too, because we want to be able to say we're going to have a bun or not have a bun, we're going to have ketchup, or they've asked to remove the ketchup. And these are true by default. So these have both a getter and setter. So with those, we actually do want to have both a getter and setter. And we would need a private backing variable in this case. And I like to use the same name for the private backing variable as I do for the property. That's a common practice in C#. The thing you have to be careful of is you need to make sure that whenever you refer to it inside this getter and setter, that you're referring to this private variable, not the getter or setter itself. For example, if I was to say return ketchup with a capital K, what I'm actually saying is, when I invoke this getter, I want to grab the value of ketchup, which is this getter, so I will invoke this getter again to get the ketchup, and it's going to return the value of this, so it's going to grab this getter and invoke it again, and we'll create an infinite loop that just never stops, an infinite recursion. And it will eventually stop with a stack overflow as the error that you would see. So a stack overflow just means we have run out of memory on for the program to use because it's been consuming too much memory. So I have to make sure that the symbol I'm using here matches the private Boolean. And then the set is going to be the same way. I'm going to say ketchup equals true. Okay, so that's one way of doing those. Another possibility is C# does something called auto implemented parameters, where we'd say something like public bool, and the next one is, or actually we should have had bun. So public bool bun, I have to add a get and a set. It's going to say, oh, you want getters and setters for this bun that is of type bool, and the compiler will actually create for us a hidden variable, a hidden backing field of type bool, and it will initially be set to false because that's what booleans get initialized to. Now we said we want the default to be true because when we order a burger, by default we want a bun with it, so we can set that default like this. So this is effectively the same as writing this out, except that the private backing variable is created for us by the interpreter. Now, the downside to that is we cannot access that private backing variable. We don't have not only permission to get to it, we don't even know what it's called, because the compiler will actually create a name that's unique for it, and it's going to be not a human readable name. But if all we need to have is a Boolean property and we want to be able to get that value, we can do it this way, and that works perfectly fine. So we would have to do that for the rest of our properties, either using this style or this style, or of course we can abbreviate this style using the lambda syntax as well. So if I move bun up here, I'll do one more example. Let's do mustard. So we could also do, and this is one of the reasons I don't like autocomplete, is it tries to force us to use what we've already declared, and what we want to declare is a private backing variable. So we could also do our getter and setter this way. which is just an abbreviated syntax. Instead of doing the curly braces, we do the lambda arrow to indicate that we are just going to return mustard. And in this case, we're going to do one statement, which is set the value coming from, oops, this should be value up there as well. Value is the parameter that's given to our setter, the sole property that, or the sole parameter that comes in, which is the value that it was set to. So we want to assign that value to ketchup to make sure that we get that value. Same thing here with the mustard, so we're going to assign that value. So this is just shorthand notation for this style of notation. Again, another example of syntactic sugar. So our list property, we're going to return a list of string, which is going to be our ingredients, or sorry, instructions, special instructions. And we need to figure out how to return that. So one possibility is we could have a private backing variable. And remember to initialize it because we want to return, have something in that field. Now, the list is a reference type, not a value type like a Boolean or a unsigned integer or an integer is, which means it's actually referencing another area of memory where this object that is the list resides. So when we return that, we could do something like this. Now the downside is what we're actually doing is, even though this is private, because this is reference type, what we're passing here is a reference to that list. So the list that they get here is the same list they have here. If they make changes to that list, those changes are going to percolate down into this list as well. So we really ideally wouldn't return this directly. We would return a copy of that list. And one of the ways we can do that is we can just wrap this in a new list string special instructions. And I'll talk to you a little bit more later on about what this is actually doing. What it's doing is it's creating for us a new list, and it's taking all the contents of the old list and putting it in that new list. So this list that gets returned is now a different list than the special instructions, but they contain exactly the same strings. Now if they make changes to this list, those changes won't affect this list. So we need to talk a little bit more about memory, and we'll kind of draw out some diagrams and talk about why that works that way. So that is one possibility for getting that list of special instructions. If we do this, then anytime we set a value, we need to go ahead and add whatever special instruction we have. So maybe if this is not true, we'd want to say special instructions hold ketchup. And this needs to match exactly the string that's given in the specification. We go back to the specification, we have hold ketchup with a capital H and a lowercase k, so that's what we need to make sure that we do here. And it needs to be spelled exactly the same as well. So that would hold it. Now on the other hand, if they change that value, once we've added this to that list, it's going to be in that list until we take it back out. So we'd need an else branch here as well. Special instructions dot, and we'll remove hold ketchup. Otherwise, if somebody changes their mind and flips this Boolean and we didn't have this else statement, that means that they would now no longer have they would think they'd remove the ketchup or put ketchup back on the hamburger, but the instructions we'd be printing for the cook would actually still say hold ketchup. So we need to make sure we remove that if they change their mind. And that would take care of that. So that's one possible way of doing that. If we do this style, we need to think about that reference type and giving a new list, and we have to add this kind of logic to our setter. The other way we can do it is we could actually generate the list right at that point in time. So rather than using this private list, we could just go ahead and say for our getter, and here we are going to want a bit of a loop, so we'll do a list string, and then we could do an if statement. If, start with bud. If we do not want a bud, we are going to add instructions that we are going to hold that button. And we would just keep doing this for all of those Boolean properties. At the end, we want to return the instructions. Now in this case, we are sending the list we just created, but every time we ask for special instructions, we are going to get a brand new list this way. So we're always creating a new list. So if the user then goes and modifies that list, we don't care. That's actually not going to hurt us at all. And if we go this route, we don't need to have anything in the setter and getter, which means we could actually use this auto property format for everything. For all of our Boolean values, which makes for a lot less typing. So you can really do this any of these styles. You can do the special instructions either way. That is one of the great things about programming, is there's a lot of ways to do these things, and we have a lot of freedom here as long as we meet these instructions here, these specifications, and we follow that, and then we're in good shape. The last thing we need to do is that toString. And this is going to be an override method. And we'll talk about what override methods actually mean when we get into the next week's material. But here we want to return the string that was specified as the value of our return string. So BriarheartBurger is what we should be returning. And we want, again, this to be spelled exactly like it's spelled in the specification, including capitalization. That's important. Okay, so that is writing that class in a nutshell, as well as a couple different ways we can write our properties that may take a little less time, although we may have to go back and change these back to this implementation if we ever need to do any kind of logic around when we set these values. The nice thing about this too is no matter how we define these properties, if we use this send format or this format or this format, if we change those in the future, it won't change any of the code that depends on these properties, because the interior implementation of those properties, as long as we don't change what they're actually returning, what type they're returning, or what they're called, the rest of the code doesn't need to change. And this is part of that idea of encapsulation. We're making it easier to modify the rest of our program or the part of a particular class without needing to worry about our effect on the rest of the program. And that's all we have for today, so I will stop there.